All right, welcome everyone to the Orange County Docker Meetup. Let's see, I see 7 people on StreamYard and several dozen folks on YouTube. So, welcome everyone. My name is Piyush, and I am a Docker community leader and organizer for today's meetup. Since it's been a while, we have had this meetup. Just as a refresher, this is a Docker community of practice. This platform is about collaboration, geeking out with the community, learning from each other's experience. I see few participants have joined us, and we're expecting more audience as we proceed further. Now, before we start our proceedings, a shout out that as per the latest Docker index, and I'll post the link in the chat in a minute, there has been a 25% increase year over year in terms of number of pulls on Docker Hub. 50% year over year increase in the number of application container repos on Docker Hub, and a phenomenal 30% increase in the number of Docker Hub accounts. Now, all these numbers continue to highlight, position Docker as a foundational platform of choice for builders in this current digital first marketplace with customer expectations evolving constantly or rapidly, right? So today we have an interesting topic about getting started with Docker on AWS, and we are pleased to have among us some local geniuses, Hans, Jeff. They're both container enthusiasts, solution architects, and leaders from AWS. In addition, we'll also have some container leaders watching the chat and answering any community questions. So feel free to throw in your questions in the chat pane. With that, I'll hand over the virtual mic over to Hans.
Hello, everyone. Can you guys hear me? Okay.
Yep, we can hear you fine.
Awesome. So, hello, everyone. My name is Hans Nesbitt. I'm by day job, I am a solutions architect at AWS. And as Piyush said, we have a few other people on here on the line with us as well. Jeff, Arvind, George, and Ramesh are also AWS employees by day. But we're here to talk to you guys about just technology and containers and really geek out. We all have a love for containers and just technology, so we're excited to be here and share this with everyone. And also Piyush, who's the Docker community hero, AWS builder. So excited to have Piyush here to help us and share his love of technology with everyone as well. A quick agenda of what we're going over today. I want to do a quick overview of just why containers and how we got here. Talk about that very briefly to level set. Next, after that, I'm gonna hand the mic off to Jeff, and Jeff is gonna give us a little bit of overview of some core AWS, concepts and services, just to make sure when we jump into some demos later on, we have a really good foundation of some concepts we'll dive into. Like I said, after that, we'll have a few demos, so excited about that. We'll have one demo that's going from just a Docker file locally to something in AWS, so 0 to something. And then we have a more advanced demo with some pipelines to show there as well. So excited for those. We would also like to make this more of a quarterly event. Like Piyush said, this hasn't been something that's been going on regularly. So we would definitely like to make this something that at least I participate in quarterly with everyone. Also have a couple other people lined up from AWS willing to come help out and talk. So at the end of everything here, we have a survey. So would really value everyone's thoughts on the survey after this of what topics they would like to hear about next. Getting started with other different topics of AWS or deep dive. So would really value everyone's input and look forward to coming back shortly with the next topic that you guys want to hear more about. But without further ado, let's jump into the quick overview of why containers and how we got here and start going. Cool. So why are companies adopting containers and how did we get here and why containers? So containers are a way that allow us to package software and standardize units and to have everything we need for that software, including the libraries, the tools, the codes, and the runtimes. That allows us to, I can run, in theory, the same container I can develop on my laptop. I can deploy into the cloud, or another coworker can pull the image and run it on their machine very easily without much configuration. Containers make it easier to manage the underlying infrastructure. We have different orchestrators that allow us to place our containers and take care of the management of what container lives where and taking care of the network and all that stuff for us. And so definitely to take advantage of the full container ecosystem, looking to operate operations. Kind of taking a step back before we got to containers, like what happened then? What was before containers? we mainly had monoliths. So what a monolith was a application that was tightly coupled, single tiered or may have multiple tiers, but there were multiple things happening on one box with shared components. And it was very difficult to scale one of these components. If one process on this, box started, ballooning and taking more resources, if we wanted to add more resource to that, we had to add another box with everything else on it. So it wasn't a very way to scale and efficiently take care of our resources. Not to mention the evolution from uh, data centers and bare metal machines to VMs, and that same transition of optimizing resources and how we place our machines. But then we evolved into the microservice architecture from the monolith, which did multiple things and was very clunky for the most part. With microservices, they're very tightly scoped. Each service does one thing, and it does that one thing really well. It's strongly encapsulated. So what that means is we have one service that fails, it doesn't affect everything else. We're able to independently fail that service, and everything else can keep functioning for the most part. They're loosely coupled, so they can withstand that failure. And we can deploy them independently of each other. If we want to update one service, we don't have to redeploy everyone. We can have a pipeline that just dedicated to update that service, which really allows us to innovate very fast. Like we said, containers are portable, and they allow us to have a runtime consistency to port things from machine to machine and have it run the same fashion, right? So to really take advantage of that, we need to automate the build, the deployment, and how we handle all of that, and the end-to-end orchestration. And there are many orchestrators, and we'll talk about some of those in a little bit of, the orchestrators that take care of the orchestration of the network, the compute, the storage, right? In addition to that, if we're focusing on our applications and making sure, we're putting that first, we need observability. We need to see into those applications and make sure we know what's going on and to troubleshoot and quickly take action upon that. And security is number one, right? We want everything to be secured along the way. And we want to maximize our efficiency. We don't want to spend so much time focusing on the underlying infrastructure. We want to focus on our application and scale our application and put business value there. So we're going to take a second here. I'm going to invite Jeff up and pass the mic to him. Going to go over a quick overview of some core AWS concepts to just make the demos and the rest of the presentation go so much more smoother. So going to jump into that. And here's the first slide.
All right. Thank you, Hans. So let's talk about our regions first around our physical infrastructure here. So let me take a few minutes to share that we understand that customers have an important business to run, and they rely on us to be highly available. We work really hard to build in fault tolerance into our design and operations. So let me give you some insights, starting with our physical infrastructure. AWS has 25 regions and over 77 availability zones, or AZs, you might hear us say. Each region has 2 independent, fully redundant transit centers that allow traffic to cross the AWS network and connect to the global network. Each AZ has multiple physically separated data centers with redundant power, networking, connectivity, and buildings. And we always build at least multiple availability zones per region so you can take advantage of our isolated yet redundant infrastructure. This is an important investment AWS makes for our customers, so you can leverage it to build highly available applications. Further, we don't use other backbone providers for AWS traffic once it hits our backbone. So let's break down the AWS networking components. Let's start with the VPC, or a virtual private cloud. You can think of that as a virtual network that's dedicated to your AWS account. A VPC spans all of the availability zones in a given region. After that, you have, we talked about availability zones. Within there, you have subnets, and subnets are simply normal TCP IP structure. It's a range of IP addresses that you assign inside your VPC. And again, those are assigned to an individual availability zone. And just a reminder, you can think of availability zones as one or more physical data centers. Within the subnets, you have a concept of security groups. So a security group acts as a virtual firewall to control inbound and outbound traffic. It is stateful. When you launch an instance inside of a VPC, you can assign security groups to that instance. Those security groups act at the instance level, not the subnet level. So therefore, each instance that you might have in a subnet inside your VPC can be assigned to a different set of security groups. And finally, we have what's known as a network interface, or you'll often hear it Elastic Interface, or ENI. And that's just a logical networking component inside the VPC that represents a virtual network card. And those Elastic Network Interfaces will have one or more IPv4 or IPv6 addresses. All right, next slide. Thank you. And so our virtual network has been designed from the ground up with security in mind. Given the design of the underlying software-defined network, many of the traditional network security concerns, such as IP address spoofing, they're not considered to be valid packets within the VPC, and they're simply dropped. We also have a number of customer-facing services that can be used to manage the security of your network, from security groups to VPC flow logs for all of your flows within your private network. And more, we're seeing customers that are using networks that have no internet connectivity and utilize our VPC endpoints and private link features to access the AWS services that they need. A VPC endpoint it enables connections between a VPC and supported AWS services without requiring you to use an internet gateway, a NAT device, or a direct connection. So therefore, now your VPC is not exposed to the public internet when it's traversing or connecting to these AWS services. And with that, I'll hand it back to Hans.
Awesome. So we went over the VPC setup, and that we have regions, which are made up of AZs, availability zones, which are independent data centers, and we could deploy our VPCs across these regions and availability zones and assign them subnets. So when we deploy our applications in our demos, the availability and coverage we're getting is that's what's behind it. When we're talking about containers, the AWS ecosystem and just what we have to, in addition to networking of the VPC, we have our app mesh, which is our managed service mesh. AWS Cloud Map, which is our cloud, when you were connecting different service meshes together or want to connect something on-prem to the cloud to have a holistic mesh of everything. Cloud Maps are a really neat tool to allow us to have that functionality. And to balance incoming traffic, we have elastic load balancers, layer 4, layer 7 load balancers to handle your application and serve the traffic and balance it in the way you need. So awesome. We went over a high-level overview of all that stuff. Let's jump into a demo here. I'm going to jump out to my IDE. So I'm working with a Cloud9 IDE. This is just an AWS managed IDE in the cloud. So same thing as you have your Visual Studio Code local. Peyush, can you change the screen there to make my screen a little bit bigger, or the screen share? Thank you so much. So let's dive into here. So I have in demo 1 here, this folder, I have a simple Docker file with a very simple HTTP app. This is a getting started with Docker app that has a simple body. And so we're going to take this app and deploy it to AWS using a tool called Copilot. Copilot is a CLI tool developed by AWS that's built on patterns we've seen from other customers using, and patterns to build successful microservice architectures. And so we'll dive into a little bit more about that as we're loading and letting everything else finish its deployment, but let's go kick it off. So we're going to go ahead and deploy a new application. We're going to call this Demo 1. And actually, we're not going to use existing application. We already have one deployed for our Demo 2. So we're going to call this application Demo 1. And here you can see some different types of services that we could have here for our container. We could have a request-driven service, a load-balanced web service, a backend service, a worker service, and a scheduled job. For this purpose, let's do a load-balanced web service. And what do we want to name it? Let's just name it HTTPD, since that's the type of container we're pulling. So we'll go ahead and name it that. And it will discover the Docker file in the directory which you're running it. So it will discover that, and we'll go ahead and press enter. makes it very easy for you to, with a few prompts from the CLI, build your environment. So while this builds out a little bit, we're going to jump over to the Copilot GitHub page and walk through a few of those other load balancing examples while we wait for everything to finish deploying here. It should take a couple minutes, but we'll check back in a second. So here is the AWS Copilot page. And so very comprehensive documentation of everything, all the possibilities you could have for your applications. So we have here under the manifest section, the different types of services we could have. So we chose the load balanced web service for our application, but we'll look at some of the different options here. We have the request driven service, which allows us to have a publicly available service that just takes requests that's driven by the request, not constantly running. We have the load balance service, which is a container that's behind a elastic load balancer, and it will handle requests as you see fit here with the paths. We can also specify the memory count and some other specifications here for different environments. In our second demo as well, we have multiple environments, so that will come into play a little bit more there. We also have our backend service. So we have our load balance service, which has our, our HTTP or our web application, but not everything always needs to be available to the web. Some things can, be available or don't need to be available to that and only need to be available to the backend. And I see a question in chat here from William Nelson. We don't need to push to ECR first. It will take care of all that for me. Once it discovers my local Docker file, it's going to go ahead and discover that and push that to ECR for me. So we'll look at that a little bit later too. So Copilot's really awesome, and it takes care of a lot of that heavy lifting for us. So with our backend service here, again, we might not need everything available to the internet facing. We want to make things as secure as possible. And so if we don't need anything, servicing traffic, we need that to be that backend for that security purpose. So this is how we could deploy a service in that fashion. And we can specify the network too if we want this private. And here's the rules for the group we want it to play for communication. A worker service, if we want to have something pulling from a queue or listening to a topic. So with even a dead letter option here. So it gives us very much flexibility for different types of services. And these services we're adding more and more here all the time for popular patterns we're seeing. So we're definitely, AWS is putting a lot of effort into developing this Copilot CLI and make it really meaningful for our customers. And we have the scheduled job. So if we want to run something on an interval every so often, have the capability to do that within our cluster. So let's take a jump back to our environment and see how things are going so far. Okay, so we would like to deploy a test environment. Yes, we would. And so far it discovered everything. It produced all the infrastructure as code we would need behind the scenes. So we don't have to take care of any of deploying the infrastructure within AWS. And after we get done with this demo, we'll dive into a little bit more of what it actually deploys for us behind the scenes. But let's take a look. And so far it deployed, it wrote our local manifest file for our application. And so we can see here, after we've went through the prompt, we can see that here is the manifest file for our service that it's created that is currently deploying right now. So this is something you could come and edit for your service that we would could add other features to from our Copilot CLI. Could come to the web page, see a feature of something we want to add, a property, and add that to our manifest and go ahead and deploy that. So we can see here we're currently deploying our test environment and all that stuff behind the scenes. So that will take a couple minutes. So while that's finishing deploying our test environment, and we went over the Copilot, let's dive a little bit deeper into what it's doing behind the scenes right now, and then we'll come back and check in on that. Let's go back to our presentation. And so behind the scenes, or what we're going to jump into now about what everything's doing behind the scenes of what the Copilot CLI handles for us. In the AWS ecosystem, we have many options for customers to run to orchestrate their containers, whether Amazon Elastic Container Service, which is commonly referred to as ECS. Elastic Kubernetes Service is EKS. For the purpose of Copilot, it deploys things in the Elastic Container Service for us. And so for this, we'll be mainly focusing on ECS. And for the hosting of containers, we have multiple options as well. EC2, which is our VM option, VMs you would manage and patch and be responsible for the underlying VMs here, or Fargate, which is a serverless container option, which AWS manages the underlying compute for your containers. So you can truly just focus on your applications. You don't have to patch the underlying compute. You don't have to secure it. AWS handles that for you. And you just worry about your application and scaling your application and nothing behind it, which is awesome. It takes care of a lot of that heavy lifting. In addition to that, if we need to run our containers at edge or on other hardware, we have ECS Anywhere. You can install that on a Raspberry Pi, on your laptop, and run containers managed by ECS Anywhere. So really cool. For the sake of Copilot, it deploys things on Fargate. So we'll dive into a little bit more about that later, and some of the constraints and other limitations we need to worry about and just look out for when deploying things in Fargate. But for Copilot, we'll be deploying things on Elastic Container Service and Fargate, and it will behind the scenes we'll be pushing things to the ECR Elastic Container Registry. So when we're running our Copilot deploy or our pipelines, the images we'll be building will be pushed to ECR. You can consume images if you have images you already have in Docker Hub or other places. You can definitely pull those images in. Just as Copilot builds it out, it's going to push it to ECR before it deploys it. So I'm going to go ahead and double click on ECS a little bit more here. And so what are some of the values to ECS? And why is it very powerful? It allows us to focus on our applications and our business logic and not the underlying infrastructure, especially when paired with Fargate. We don't have to manage the underlying compute. I worry about the application and how my application scales and how my application secured and securing my containers. And again, focusing on business logic and making a difference for our business and not focusing on underlying infrastructure and scaling that. As built-in integration, so once the environment's a little bit back up, we're going to dive into some of the CLI commands and see the other integrations and what else we can do once we have that environment up. But we have turnkey integrations when we want to deploy a NoSQL database. We can easily, with Copilot as well, request a NoSQL database, and it will manage and deploy that into our environments for us. We can integrate with S3, which is our blob storage, and as well as Aurora, which is our managed relational database, Postgres and MySQL. I think for the Copilot, it's Postgres right now, but we'll double check when we jump into the CLI there. And it's enterprise grade. On the Fargate page, we can jump into that too, but lots of different security and compliance regulations certified to meet what you need there. And improved TCO. Since we're only deploying our applications and managing on Fargate for this, we're not having the compute that's spent there that we're not using. We're deploying just containers and optimizing our containers and the size of our containers to really have a smallest footprint as possible and having a high TCO. So let's jump back to our application really quick. It should be done deploying here, or just about done. So let's see what's going on here. What is it currently doing? So it's deploying our VPCs. It's deploying our subnets as well. And so behind the scenes, it's deployed our virtual private cloud, our VPC. We are in the region of Oregon for this demo. So it's deployed in Oregon, so US West. It's deploying subnets across multiple availability zones. So when we have one container, it will be in one data center. But when we have multiple, it will be spread across multiple data centers. And with the load balancer in front of that, our traffic will be distributed across different data centers. So we're able to be highly available and withstand failure and just maintaining best practice there. And so this will come up here in a little bit. And we can look behind the scenes too. And so we'll jump to our AWS console. And if we look at CloudFormation, so behind the scenes, Copilot creates CloudFormation. CloudFormation is AWS's infrastructure as code language. You may be familiar with other infrastructure as codes like Terraform or things as such. But Copilot will create CloudFormation behind the scenes for you. And we can see here that being created. And so the infrastructure roles, the environment, the service, and the cluster have all been created here behind the scenes for us. And if we want to double click on this, for example, to see like how many lines of code did it write for me, right? How much is it taking care of? Well, let's see. If we go to our template, we can view this into Designer as well and see here from the template, there are quite a few resources that it's been created here for us. You see this map ahead. And I'm just going to scroll down to the end of this to see how many lines of code this template has been written for me. And we can see here that's 957 lines of infrastructure as code that was written for me from one command, Copilot init, and filling out a couple prompts. And that wasn't the only infrastructure as code. There was the other two as well that we saw for the infrastructure roles and for the environment. So really it's provisioning all that for us. I don't need to focus on infrastructure as code, really just focusing on my application here, which is really awesome. And so we'll jump back, and our load balancer should be coming up. And when it does come up, we'll have that prompt here. It'll say, go ahead and visit your load balancer. Cool, so wait a couple minutes for that. It should be up shortly here. And it's not, once that load balancer comes up, I want to dive into some of the concepts here and some of the commands that we're going to run after this to look into what Copilot provides. So we have our application. Our application is our highest level wrapper of it. This would be, if we have an application, this is how we would want to isolate it, right? An application typically has multiple services. An application has multiple environments. So this is the highest level wrapper. Like I said, we have environments. Environments may consist of dev, prod, stage. There's much flexibility in Copilot to name the environments whatever you want to name them. By default, it will ask you if you want to create a test environment as such when I went through the prompts. As well as service. A service is how we're distributing the load for our application and describes our application a bit more. So these are some of the key, the application, the environment, and the service. You'll see when everything's stood up and nice and going, we'll run through those and look at what we can get out of this service and describing us and showing us some stuff there. Jobs, which we covered, which initiates jobs or scheduled jobs. And there's pipelines. And pipelines is something we'll cover in our second demo. We have a 2 environments and a CI/CD pipeline built out. So really excited to show you that one here in a second. So let's jump in here. Our task is being created and rolled out. And that's pending. It says revision 5. I deployed this earlier, I must admit, and ran through a few. And so that's why you see revision 5 there and not revision 1. If you were deploying this for your first time, you would see that be 1. Cool. So this should be up here, our task rolling out. And we can even jump to ECS here and take a look. So like, what does the console for ECS look like? What's going on here? So we see here's our demo cluster. And we can take a look at that. And we can see here's the service that we've created. It's running 1 desired with 1 running. That's what we described in our our file there. And we can see here the target group and how it's listening on what port, and all the other VPCs and the subnets and the security groups that Copilot created behind the scenes for us. We can see our tasks. And we can click into our tasks a bit more to learn more about them. So I'm going to go and click into the task we have running. We can see the task here and learn a bit more about how that task is placed, its ENI, its subnet, its IP, and even learning about the logs here. We can start seeing here that there are the containers logs. So if we jump back, I bet we have a load balancer up. There we go. I'm going to go ahead and copy that, and we will bring this up. And here we have our container up and running, serving traffic to the internet. So from one command, Copilot init, and having a Docker container and just an HTTP HTML file locally, I was able to create all the environments, push all this out into AWS with one command. And not just that, how because of the patterns that we've seen with Copilot, we're able to have those deployed in a least privileged pattern. So the service, the container you've seen there has only permission to do what it needs to do based on the context you give it. It doesn't have it's not overly permissive, it's based on least privilege. And as we put apps together and say this front end talks to this, we're continuing on these least privilege, which is really cool. So let's dive in here a little bit. Let me bring this up on my screen. It's blocked a little bit. Cool. So let's do Copilot service show. And this is going to start to tell me about my service now. And so we can see here some environment variables that are available to my service. If you were in your container in the environment and you looked at your process environment variables, these would be available to you in there. So really powerful as well. And as we add other things to our application, for example, Copilot storage in it, let's go through adding some storage, for example. So if we were to add some storage here, add either our DynamoDB, which NoSQL, S3 for object store, or serverless Aurora, a SQL database, we would go through those prompts. And that also, that database then would be populated as an environment variable for each environment. And so it takes care of all that heavy lifting for you. So you can really standardize upon, here's the environment variable I'm pulling in for my database connection. And that should be the same environment variable for each environment. So we're not changing things each environment. It's standardized, and we're able to deploy it once in one environment and be pretty confident it's going to work further down to other environments. So really awesome thing there. So we're able to dive into our service, and I'll scroll up here a little bit. You can see the environment variables available to you and their values. The service discovery as well. So if we were to deploy other services as backends, we could discover them as such here and see them all listed. If we have different environments, as we will in the second demo, you will see each environment here and the URL to access that. Some configuration about the environment and how it's configured. So able to use the CLI to start digging in here and discovering about it. We can also start looking at logs from here as well. So from just the CLI, I don't need to log into the console. I can go to ECS here and look at all the logs in here, or CloudWatch, which, this is the same thing, pulling from CloudWatch, which is AWS's built-in monitoring solution. So you can go to CloudWatch, the console, to pull that as well, or a dashboard. But we can do the same thing and pull the same data from the CLI as well. So really powerful. And we can even put time ranges on that to say, only show me the last 5 minutes. So from the CLI, we're able to deploy things easily and start digging in and making sense of things as well from our environment or from our application. We can also see our environments. So we'll do an environment show as well. And so we can see here, we have one environment, and it tells you here's the region it's deployed into, the account it's deployed into. And with Copilot as well, you could deploy into multiple regions. I could have deployed a region in East and in West and have facilitate to that. You can have Copilot deploy into other accounts. So if you wanted to have each thing physically in different accounts, something right there too, right? So for this purpose, all in one account, really simple demo. But we're powerful, and we can start doing things and seeing things here with the CLI. We looked at logs, we described our service, we looked at our environment, and we can look at the application as well. There's not too much info with the application since it's the highest level kind of structure there. This tells you a bit about it and the services within that application, the account you're in, the region. So very simple, basic information there. But let's make a change to this, and then let's push that and keep going and talk about some of the stuff all this change pushes. So let's just type change here. Then what would I have? Normally, if I wanted to push a change, it'd be really difficult to push changes to other places. But with Copilot, pretty simple. Don't have to push to ECR even. I just type Copilot deploy in my directory, and it will go ahead and find all that stuff, package it for me, push it to ECR, and roll out my new container in a couple minutes. So really, I'm able to just focus locally on that and use Copilot to push my application to the cloud when I need to. So really powerful there. So with that, let's while this deploys and keeps pushing, we're gonna jump back into the presentation, go a bit further into ECS, and jump back to check that out when it's done, and then we can jump into the second demo there as well. So, all right, with ECS, the cluster manager and the placement engine are really core components of it. The cluster manager takes care of bringing up compute to make sure we have enough compute to service our containers, and the placement engine takes care of placing those containers on that compute. And we're going to go through a similar thing of kind of the structure of the ECS cluster as we went through like the structure of the VPCs and the availability zones and whatnot to really dive into that in the app kind of, and it will link some of the terminology we're diving into with Copilot as well. So the ECS cluster is a way of isolating and grouping resources. It's also a way to put a permission bound across everything. We can limit what our services can do, but we can also limit to like, hey, you're bound to things within this cluster, right? So it allows us to strengthen security as well. Within the cluster, we have cluster instances. This could be if we're not using Copilot, this could be an EC2 instance or a VM that you have behind that hosts your containers that runs your application. For Fargate, you don't have to worry about the container instance. That's managed for you and runs one container isolated. So no worry about security there, all managed, secure. The task definition, a lot of this, so we have the tasks, our service. So the tasks define our containers. They're very similar to when we looked at the manifest for our Copilot. It defines the memory, the resources, the containers, if there's sidecars that we need to install as well. How are we doing logging? What permission set do we want to assign? And all that fun stuff. So that's what our tasks define. What does my container look like? And then the service is the same thing. How do I want to distribute load across my tasks? Do I want to use a ELB? Do I an elastic load balancer, layer 4? Do I want to use a layer 7 application load balancer to route traffic dependent on path? So we can use the service to distribute traffic as such. It takes care of the load balancer and service take care of replacing unhealthy tasks, take care of making sure all that is healthy and routing and traffic to the correct healthy instance. And so from the hierarchical view, again, looking at this, the cluster is the whole wrapper that is deployed to a region. So the cluster in ECS, again, regional construct deployed to Oregon in our example here. Our service is made up of one more tasks behind that, and it tells us how we distribute traffic and making sure that when we're sending traffic, it's a healthy instance or container we're sending that traffic to. Our task is made up of one or more containers if we're running sidecars, and allows us to specify compute, network, or just other configuration for our containers. The compute I'm going to double click on for a second here. In addition to, we talked a little bit about EC2, which is our VMs, and we talked about Fargate, which is our serverless compute option. But I want to double click on Spot here. Spot is our AWS's preemptible instances where if you have an instance, it's really, take a step back. If we have an application that is able to withstand failure, is able to have resiliency, so stateless applications, microservices, the task that doesn't write anything locally, just takes the request and passes it on. So things like this that can, if a single task fails, a single container goes away, it's not a terrible failure to the application. For applications like this, we can run on Spot. Spot is a discounted excess capacity that we have on AWS that you can request at a discounted price, and that may be reclaimed within 2 minutes. So if we have a service that can withstand interruption and we want to optimize real heavily for cost and take advantage of that, we can take care of Spot as well, use Spot as well, and Fargate Spot upon that. And in our tasks, in our manifest files, we can specify scaling as well, and scaling between our Fargate or Fargate Spot, and when we want to scale to Fargate Spot. So with Copilot even, we can be very granular and say scale from 1 to 4 on Fargate and then go to Spot beyond that. And in addition to that, we can do other things behind the scenes like savings plans or reserved instances, other concepts in AWS that allow us to say, hey, I know I'm running this amount all the time. I want to like pre-purchase and prepay to save money up front and saying, I always know I need this much compute. And so there's other things we can do too to make sure if we have always running compute that we're just optimizing and being cost conscious all along the way. So I wanted to mention that as well. So we have Spot and Fargate Spot. And so we have a workload that can withstand interruption as a microservice that can, if one fails, no big deal. Spot's a great option. It will allow you to save cost as well there. So really take a look at that if that's something that makes sense for your application. But definitely if your application can't withstand failure, it's writing to a local volume all the time, and maybe Spot may not be the best thing for that application right now. And again, ECS, the control plane, the management, the section is serverless. There is no cost or no management that you have to do for running the ECS control plane. It's fully managed for you. With ECS, the only cost you ensue is when we start talking about the compute and storage and things that goes on in our environment. For ECS itself, there is no cost for the orchestrator, just the compute and everything else for our applications. And with Fargate, we don't have to worry about managing or backing up or securing or upgrading all of our EC2 or VMs that we have behind the scenes normally. That would, in previous lives, in managing and patching, VMs or even bare metal machines, that's a real nightmare, and it's real scary to do. And containers, make it a little less scary to do that. It's secure by design. Each task is isolated. We're able to scale the Fargate tasks themselves, not scale the VMs behind them, not worry about that. And really, like we said, if we need to optimize for cost, Fargate, Spot, and savings plans are real good options. And improved TCO, we talked a little about the control plane for ECS. There's no cost there for you. The control plane's automated end-to-end orchestration, nothing you have to worry about. Tell us how your cluster wants to run, and we'll run it for you. Fargate is fully managed data plane, so you don't have to worry about anything else, the compute behind your containers. Just pay for what you provision. So we're able to be really cost conscious in focusing on with Copilot. We're deploying one container or a set of containers in a service, and I don't have to pre-provision anything else behind the scenes that may run up costs. Just deploy your application. For example, I have mine that I was developing on for the second demo, just scaled to one, very low, resources applied to it. So I'm really able to optimize there, and just when you want to get started and get something going. But when we develop applications, in how we saw in demo 1, right? I did something locally. Let's put it up in the cloud and get it running and start developing more and more, right? That cycle is not all we need to do to be successful in production, right? We do need to continue to build in an automated fashion and push to our environments in an automated fashion, because that is best practice. We don't want to do things manually. We want to automate it and do it that way to make it most reproducible as possible. But after that too, we need to make sure we're orchestrating it in our environments, multiple environments, and orchestrating our deployments into these environments. And when we're deploying between environments, we may have some tests we want to run. We want to make sure our application's healthy, and if we make changes to it, that we don't break our application before we push it to our next environment. And beyond that, we want to be able to dive really deep into the monitoring and health and metrics of all that. So we can develop, push it to our environments, have the CI/CD go, and continually optimizing and do that. And that's more productionized than doing the Copilot deploy. So in our second demo, we'll be diving a bit deeper here into a more advanced use case here. So I'm going to close these up a little bit, and let's minimize this and go into demo 2. So in demo 2, I have a few things pre-provisioned. I have a pipeline pre-provisioned, as well as a Node.js app. So let's walk through a little bit about the app, since it's a bit more complex, and then we'll dive into the rest. Okay, let's look at our Docker file first too. Our Docker file here, We're installing, this is a node application we're running. We're installing some AWS SDK things in our container and some other just libraries we need for the application. It's a very simple application. There's it reverses the text you send it, so you can curl it with hello and it will send you hello in reverse. So very simple, just some libraries that allow us to do that very easily, as well as Express that allows us to serve our traffic or does our app hosting. So let's look at our Node.js app here. So for this as well, I've implemented some APM to this as well. So we're going to look at that. I added a few lines of code here, and it's called X-Ray. It is our AWS's APM. Allows us to do tracing and really dive deep into the health of our service. So we'll look into what we're able to get out of that, the console here in a second. But let's look at this file for a second here. So we looked at this. I pull in just my X-Ray, my normal AWS SDK, and the rest of the other SDKs that we saw in the Docker file. We pull all those in. We load our app and say this app's going to be serving on port 3000. In addition to that, we saw earlier when we looked at the environment variables for our container, when we looked at like the service and we saw the different Copilot properties. So here I have those environment names and service names available to me as environment variables. Again, if we did a database or something else like that, we would have those environment variables available to us like this to consume within the app. And so I'm able to say, hey, this is this environment and this service, and we'll see that reflected when we look at the console of some of the APM stuff we have there. But then the simple app here, just on a post, so on a send request, reversing the string and sending it back, and having just a simple hello world as our GET request there too, and saying close the segment. We'll dive into that a little bit in a second, and just closing, saying we're listening on this port 3000. So pretty simple app, a little bit of code there, not terribly much. And our test again here, we'll look at that. So here's the test we'll be running in our pipeline. This test does the reverse string, so it sends hello and expects the reverse in response. So in our pipeline here, with our pipeline file, we're able to not just do CI/CD with Copilot that takes care of provisioning all the resources for me, but I'm also able to test my application to make sure when I push something new, I'm not breaking anything, right? So that's really, really nice to have there. I want to be able to push my application, make sure it keeps working, and then if it passes its test, keep going to other environments. I only have one other environment for this demo in production, and I have a approval trigger for that. And we can look at this pipeline in the console a second too. But let's look at this build spec since not the build spec. When we deploy pipelines with Copilot pipeline, and we can see here too, I'll type Copilot and switch to my demo2 directory. If I type Copilot pipeline in here and show for demo2, it shows us the status of our pipeline. And so don't have to go to the console to see the status of my pipeline. I can see the status there, the show the pipeline, and see the status of the pipeline as well. And it failed there. I didn't approve or didn't pass the test commands. All good. So we can see here that able to look into our pipeline and get that data out. And let's look at this too. So for this, with the pipeline, we pointed at a Git repo. For this, I'm using code commit, which is AWS's hosted, Git repository. So I sync to my Git repository. I push my code to my Git repository, and then I said Copilot pipeline, init, and then I created my pipeline from that, and then I can start CI/CDing. So it's pretty simple. And let's take a look at what the pipeline actually looks like. I can go to code pipeline here. And see my pipeline. Here's the source. So once it checks in to my repository, it will go ahead and build the code. And so that build spec that you saw there too, that's created by code pipeline. We didn't have to write that build spec. I didn't have to create it. Just as we run our Copilot pipeline init, it creates that build spec for us. So really handy as well. And so we have here is our environments. Our test command failed, and we have our prod environment. So we can see here from the pipeline, we're able to deploy environments and easily create a CI/CD pipeline based on Copilot without writing any code. Did not write the build spec, did not write the CloudFormation or the infrastructure as code that deployed the pipeline either. Just simply use Copilot. So really powerful. So let's take a look here. I have my pipeline, my build specs there. I have my Node.js file, my application. Should all be good. So let's make a change here and check it in and watch the Copilot, the pipeline take us away. So I will go ahead and git add this. Commit. Add a comment there. And we'll go ahead and just push our changes to our branch there. And we'll go ahead and see this start flowing in a second here. This will go ahead and pick up and start rolling through. And so the pipeline takes a little bit to deploy, not to fully go through. The build maybe takes a couple, 2 or 3 minutes to fully build everything, since it's making sure all the CloudFormation is built and intact for your other environments. So that way, if you update your environment as well, this will take care of the updates to your environment along the way and updating your containers. So again, no focus from us on any infrastructure. I'm simply able to focus on what my application needs. My application needs multiple environments and these tests and to run like this, right? So let's take a look. I'll refresh this. And there we go. So we did our source and we started to build, and now the pipeline's flowing through. And we'll let this continue to go. And let's see if we can Copilot service show. Let's see if we can get our front end here and see if we can get a response. So we can see a hello world there from our application, and I'll add a echo there to break that line up a little bit. So I hit the post, and I was able to get a hello world response. So that's what my application was expecting. And now I'll add a text here and let's add hello and get that response. But let's change it hello, because you saw hello in the text there. So we'll say hello Docker, and we're able to get that. So our service is up, it's giving that traffic, and it's still allowing us to push updates to our service. So really cool there. All right, let's check in our pipeline, see how it's coming along. Still building. Like I said, the build may take a minute. It has to go through all of the different CloudFormation creation to make sure each environment you have and all the parameters for that environment are concise. Earlier, we did to push to the first demo 1, we did push a change, and I'll go ahead and refresh this really quicker. Now you can see here now. Granted, it's been a while since we did demo 1, so I expect the change to be done. But there it is. So just to say, from our Copilot deploy we did for demo 1, that's there as well, and that change push. While we wait for the pipeline to finish, let's go tear down our first demo. So we stood up something, and we did a test. CD, not Copilot. We stood up. We deployed our demo 1. We updated it. We're happy with it. And so now, how difficult is it to tear everything down from that app? You just type Copilot app delete, and it will say, do you want to delete that application? And you can say yes. And that's the only thing you have to do to delete your application and clean up everything from your environment. You will have to clean up a few things in like your directory structure. For example, for demo 1, I would have to delete this Copilot folder, but everything in your AWS account that Copilot app will delete will clean up for you. So very easy to stand up and very easy to clean up as well. I'm going to open another terminal while that finishes. the delete so I can keep going with some other stuff here. So another really cool thing too about Copilot, look at demo 2. So we have Copilot service exec as well. So say we want to get into our container, like, hey, I want to check out, make sure that something is configured correctly, and check it out. So instead, we don't have to log into the server. We don't have to pre-provision credentials. We can run Copilot service exec, and that will allow us to exec into our containers. We did have to specify, or I did specify exec, or you can specify no exec. But for this, don't have to worry about any credentials or rotation of credentials. AWS handles that for you. So really easy from like a Bastion perspective. Not a lot of footprint for any attack surface. Everything's managed by AWS here. So for example, I want to, what environment do you want to go to? I'm going to go into my test environment. And so now from my CLI, I'm now into my Docker container, my ECS task Fargate, and I can look into that container. And so here in my test environment, I can see in my container, my index, my node modules, my Docker file. So easily be able to get in, troubleshoot, look at logs, get into my container from Copilot, deploy, tear down things. Just makes, I keep saying it, but it's so true that you don't have to focus on the application, or don't have to focus on the infrastructure. I'm able to just focus on my application and focus on it a lot. One thing we didn't look at yet, though, is that APM section, right? We did some implementation here of X-ray, right? And so what's that mean? Oh, the build's done. It's deploying. All right, let's go. So let's look at the APM. I have at the end, I have some useful links as well. There is an ECS Workshop here too, if you can see the ECSworkshop.com. So this has not just the getting started that I did with Copilot. There is some of the getting started with here on microservice architecture to Copilot. There is a Copilot path here, but there's also many more modules here. So this is a really good resource to go look at if you want to learn to do other things or looking for other hands-on labs to do for ECS. Really good lab here. We have other ones for EKS or Kubernetes and whatnot. Would love to have our next session when we come back and maybe beginning of next year, be getting started with Kubernetes on AWS. And so I think maybe that may be a good topic for next time, but I'd love to hear everyone's feedback at the end. And to William's point, this is a really good resource, the ECSworkshop.com. Content that AWS SAs or other people develop and putting effort into this. So more content's being added all the time. So really good place to check out for all things for ECS and different contents. But jumping back to our observability, we deployed some APM, we put a couple lines of code in, but what does that get us in addition to that, right? So you can see here that we have our services, both environments. There's prod reverse service and test reverse service. So from our environment variables that were exposed to us, I'm able to consume those, not hard coding anything, and each environment is able to distinguish itself. And I'm able to come in here and look, oh, here's my prod service, here's my test service. In addition to that, I'm able to dive pretty deep in here of, let me view this as a dashboard, to the metrics for my container, my latency. What are my average requests, my faults, my requests, my OKs, my errors, my throttles. So I'm able to really dive deep here. If I have multiple nodes, you'd see that in the error rates. You can see the percentage here. So I'm able to, with a couple lines of code, and that you can do this in multiple languages, not just Node. You can do this in Python, Go, or whatever have you. Check the AWS documentation for that. But able to, with a few lines of code, implement tracing into my container as well. And so I'm able to not just deploy my container with Copilot. I'm able to now start taking advantage of some other cloud native services and able to really dive deep into my container. And now I can start testing my container and really pushing the limits of one container in my environment to start getting some meaningful data of how my container is acting. And then I can have some really good data of what production or staging, how do I need to size it? Do I need to scale quicker? Do I need to do those things? I can do all that based off data. And that just makes the job so much more easier when we're not guessing and we're using data to make our decisions. All right, let's see. Where is our pipeline? Are we along the way? Did it fail again? Are the demo gods not with me? Let's check. Oh, it's in progress still. That's a good sign. Okay, so our change is pushed and our test command's running now. So if our test command passes, our changes will be pushed to our environment. If our test command fails, it will roll back. And if our test commands progress, then we'll have the option to approve our promotion to production. So it can put gates in place to make sure we're not just rolling out to an environment that we want to control what's put there. Very cool. We'll let this run. In addition, if we go to the pipeline here too, we can double click in here and look at the build logs of what's happening. This one hasn't spun up yet, but we'll jump back to, for example, this one. We're able to jump in and we're able to, this one's CloudFormation, but if you clicked it, we're able to dive in more and see what's going on. Right now we're making infrastructure changes. So this is the demo one still deleting and going along the way. But if you're making changes to your CloudFormation for any changes we made previously, you could check into here, the details, and see what's happening. If you had a failure, if your CloudFormation, really good way to troubleshoot as well. Come in here and start troubleshooting. A little more advanced, but jump back to that. Okay. So our service is up. We're at our container. Let's see what else. Well, that finishes. Let's go a little further in our presentation here. So with Copilot, we're able to focus on applications, not infrastructure. We don't have to manage infrastructure to our requirements. Our application specifies our infrastructure requirements. We're able to scale. We can specify more containers in our specs of how many we want statically, but we can also specify how many we want, to scale from 1 to 10, and even across Spot. And we're implementing security and isolation by design. This is the service we're deploying with Copilot. It only has access to what it needs. It's not overly permissive, and it's locked down to its ECS cluster even. So really heavy conditions and security putting on this on everything we're deploying with Copilot based on best practice that we've seen. So for that as well, I want to dive a bit about more security and double click on that for what we mean by the IAM roles that are assigned to it. If the cluster itself or the EC2 instance had a dedicated role on it, and like for the EC2 instance I'm running on for my container when I'm doing my demo here. So for this for this CLI, this is a VM that it's running on, right? So this has credentials to it. If I were running multiple containers on my IDE here when I'm doing testing, they would be sharing the same IAM credential that I have for this box, right? They would have the same access to access other things in AWS if I'm just developing locally and testing my applications, right? When we're in production and we're in our actual AWS environment, that's not where we want to be. We want each application to only access what it needs. So if the dog service is writing to one bucket, only dog service or that container should be able to write to that location. And if we have a cat's location, only the container that's servicing the cats should be able to write there. So we want to isolate and not just who can talk to what, but what can they do in AWS, right? And that's least privilege as well. And when we specify things with Copilot, we're able to say, hey, this service needs a DynamoDB or a NoSQL database, and that locks it down as well. So implementing security at every layer, least privilege where possible, and making sure it's applied along the way. And like we said, we are deploying to ECR here as we package up our applications and push them out. Copilot and the pipeline that we've deployed will push things to ECR. So ECR is a fully managed container repository. It's secure, highly available across a region, and it simplifies workflows. For example, for our Copilot workflow, very simplified our integration and how we're able to access it with AWS. The Copilot CLI itself takes care of the permissions to even ECR and saying, this build can access ECR and things like that. So and all the automation, it's greatly simplified with Copilot, and it's taken care of for you. We can still use Docker Hub and everything else if we have other images that we have that we want to pull from. And from our Docker file, we can definitely still specify Docker Hub in our Docker files where we want to pull from. But as we use Copilot, we'll pull into ECR. So with that faster time to market, we don't have to focus on infrastructure. The integrations are there with different databases. IAM for least privilege. We don't have to set anything else there. Copilot takes care of that for us, and Fargate gives that isolation to make sure that that container is secure as well, giving us that enterprise-grade security and compliance, and improved TCO from not having to worry about scaling other things behind the scenes, the VMs behind the scenes, having more compute than we need available at all times, things like that. We're improving our TCO by just focusing on that and abstracting the developer pain away with the Copilot, the CLI, with just the command of Copilot init. We were able to set up our entire environment. With Copilot deploy, we're able to roll out a new version of something if we wanted to. With our second demo, we were able to use Copilot to build a pipeline to deploy to multiple environments and put checks along the way to make sure their application is working. We can easily use Copilot, like we said, we're focusing on application. We implement APM with a couple lines of code. We're able to just make that application give us so much more meaningful data to make sure we're able to tune things and scale according to our application. Best practices are great for standards of how we should go about things, but we want to be listening to our applications to what we should be doing. And Copilot allows us to do that and focus on it and just allow that to abstract a lot of the challenges away for us. So let's check back in really quick on how our pipeline's doing real quick and how that's all finished up. Oop, looks like our build failed again for our test commands. Let's see what the log said here and what it expected. So here we got it, the test jest. So it looks like I have a misspelling somewhere perhaps. Let's see. In my Copilot CLI or my pipeline. Do I have a jest instead of test there? Yes, I don't think I do. But for this as well, we can take out, where is this? Yeah, that looks all good. Take out this really quick too, and we can update the pipeline even too. So let's see how quick it is to update a pipeline. So if we wanted to take out that approval just to push to prod, if we did Copilot pipeline update, and this is saved, yes, we want to modify the existing pipeline. Copilot will go ahead and seeing that the state changes we made to our file of removing those tests, Copilot will go ahead and deploy those changes to our pipeline. The same thing we wanted to add tests, we could add that back in and redeploy it and have those changes there. If we wanted to add another environment, same thing. If we have multiple environments when we're starting the Copilot pipeline CLI process, it will ask us, do you want to add these other environments? And if we don't, we can come back here and just add the other environments by copying and pasting and changing the name to the appropriate environment. So here we took that out. And if we go back to our pipeline here, that should be removed, and we can just retry this really quick, and we'll go from there. So we'll kick that out. We'll kick our pipeline off again, let that go. Should be able to check that in. Git commit, remove tests, git push, origin main. Oh man, I'm sad the demo gods were not with me. Maybe next time with the Kubernetes one, it'll be a little bit better. Apologies on that. Cool. So we push out the pipeline changes again. So now the tests we committed to our source, we've updated our pipeline, and now we're going to go through that build again. So it's going to take a minute. We can come back to this, but we're going to go through that again. We've taken the build out, and we can flow through the different environments here. And so really easy, allows us to update our pipeline. Pretty easy. Previously, if you have written CI/CD pipelines and other, CloudFormation, CDK, or any other infrastructure as code language, it can take a decent amount of lines of code to get all that right and to write your build specs of how you build the application correctly and configuring for each environment how you push the configs to that environment. So there's a lot of challenges in building up a well-done pipeline, and Copilot abstracts a lot of that heavy lifting away. like I said at the beginning, it is opinionated. So there are the standards there for the services and how we want to deploy the manifests and the types of services we can deploy, the web-driven service, the load balance service. And there were some limitations, but we're adding all the time to the storage that you can add, right? You could add the DynamoDB, the S3, there the relational database. So if those don't fit to what you need and want to go a bit more than that, there are some customizations you can do with Copilot for further automation. I did that a little bit to get that APM working. I needed to deploy a little bit of a extra permission set to make sure those permissions were intact. And so in our service, we're able to have an add-ons file and have other CloudFormation or things specified in here and be able to deploy it as well. And so if we want to specify another policy that's not part of that, or another security, other things, we're able to deploy that infrastructure as code alongside if we need to. But if we needed to, everything else we can add through here if we need to. But sometimes we need to do other things. And if you need to go outside the bounds of what Copilot is opinionated of, AWS does have other options, a Cloud Development Kit, CloudFormation, or other options that we can cover in a future session. But this session was definitely focused on what's the easiest way that we can get a Docker file up from nothing to something, and then start iterating on it and making a meaningful application without focusing too much behind the scenes. And that Copilot is the best way to currently do that. So able to get that here as well. The Copilot, the manifest, and the other resources if we need to. All right. Cool. Any questions so far? It looks like we're doing okay. Does the Copilot integrate with Secrets Manager or with within the manifest? So I don't believe the integration with Secrets Manager is there, but let's see. There is a Copilot secret. I believe it stores the secret in Systems Manager. I'm not sure if you think you can reference something in the path. Looks like Jeff mentions you can reference something in the path there. So looks like there's integrations there, meaning would add to the turnkey integration. So we'll also add the roadmap for Copilot is also open source and it's on the website. If we go to the GitHub for Copilot, we're able to have different feature requests here, the pull requests and different issues. So the roadmap for Copilot is open here and able to take a look at that. In addition to just the Copilot roadmap, the AWS roadmap itself is on GitHub as well. So if you have different features or different things you want to see, a great place to go and request it or +1 something you see that's there. So if there's other things you want to see out of Copilot, you want another type of database, you want to use, DocumentDB, which is our hosted Mongo type. There you can see the request here and can go add one if that's something you want to kind of have influence on and see in the product as well. So I wanted to call this out. So if you want to see what's coming soon or anything else, like here's X-Ray as a sidecar. You guys saw a little bit of that today. So something right there you saw fresh. So definitely a good resource to look at. The Copilot, this GitHub, the ECS Workshop, the AWS Containers GitHub, all the good resources there. So let's look at our pipeline one last time. And we're deploying to test again, rolling through. That should be much quicker because we don't have to run the test. And then we should be rolling to production. We can go ahead and improve that there as well. Cool. So we'll jump back to the presentation here. Look at useful links here. If you want to take a screenshot of those useful links, please do. The GitHub CLI, Copilot CLI, the ECS Workshop, the containers roadmap for just all things containers AWS, and a link to our survey. Definitely, if you would please take a minute of your time to fill out the survey, would greatly appreciate it. There's a few questions there of just how we did here today. We would love to hear. In addition to just what would you like to see next? Like we said, this as PU said at the beginning, the community hasn't had too much going on lately. Would love to change that with everyone's help here of making things meaningful for everyone and just have something that we can do every quarter and come back with things you guys want to hear about, and then just keep on going and sharing knowledge and geeking out with everyone here in Orange County. So I appreciate everyone's time today. We can double check on the pipeline here. But if there's any other questions or anything else like that, please post it in chat. I appreciate everyone's time and hanging out with us and geeking out on some containers. I hope everyone enjoyed the session and learned a little bit. Feel free to reach out to us here if you have any questions. Oh, there we go. Jeff, parameter store set. Yeah, parameter store. Okay. So definitely reach out to us if you have any questions. Excited to come back in a couple months to talk about another subject and have depending on what topic you guys would like to hear more about. Already have a few people lined up that are excited to come talk tech as well. So really excited to make this something that we do every so often and build that relationship with everyone. Any other questions we have? Looking at chat here. Don't think so. Awesome, Jim. Glad to hear it. Definitely helped me. I enjoyed, not my first time playing with Copilot, but I played with it a first time maybe earlier this year, and definitely, really easy to get going, having to do all those things. William. Oh, we got to deploy to prod here, waiting approval. Let's go ahead and approve this. I'm going to approve it because I did the change. Awesome change. Definitely going to be approved. Cool. And now we're deploying to prod. So with our gate check there, we're able to say, hey, throw something in front of this to not just automatically deploy to prod. Make sure that I test that first. And so something easily do with just a flag there. Very cool. Thank you for posting that survey link in chat there. Please, everyone, if you don't mind, take a minute to go through that. Would love to hear your feedback and make sure we continue to make these sessions as meaningful for everyone and local as possible. Cool. Well, I think that's all we had for today from me. Went through all the pipelines. We've reviewed Copilot, the heavy lifting it takes off our plates to make sure we can get an app going quickly, how to easily integrate some monitoring as well along the way to really focus on our application, and how to even do it with a pipeline to multi-stage environment. So covered a lot today, I know. It was quite a few things we covered, but thank you for everyone for hanging in there.
Okay, well, amazing demo, very insightful. Thank you, Hans. And thank you for our audience as well for being there, asking all these questions. And as mentioned earlier, this is our local Docker community of practice, and we have these communities across 7 continents in 80 plus countries, providing mentorship, in-person online events, workshops, trainings, and we're also excited to hear about all the interesting ways you're using Docker. So if you would like to present anything Docker, feel free to reach out to us. I'll throw in my email address in the chat. Right. We'll look forward to hear from you. Anything you would like to add, Jeff, from your side?
No, thanks for your time. Hope you enjoyed it. And like Hans said, we're always looking for feedback and how we can improve. So please take the time to fill out the survey.
Thank you, everyone, for your time. I hope you enjoyed the session. Hope you learned a lot, and looking forward to sessions in the future. All right. You should see that infrastructure being deployed here. And there's our update to prod pushing along. So really cool. Updates pushing out. The other thing I'll call out too as we're just chilling at the end here. For some of the resource constraints, like how large can I have my containers be, right? If for building an application, we could look at the ECS and Fargate limitations. And so for tasks, memory, and CPU, here are some of the things we would want to currently be around for how much resources we could allot a container. If you need more than this, if you want to go to a very, very large container for other purposes, may want to look at not using Copilot currently, using CDK or CloudFormation, and deploying on a VM or EC2 instance that you manage, so that could be a larger size. So one thing I wanted to call out there too, from how large can your containers be with Fargate, something that we want to take into account when choosing Fargate 2, if we have a very large container. Cool. And it's updating our service, and it should be good. Sometimes CI/CD is not terribly exciting, right? And it's like, oh, my pipeline's running. Great. Look at it go. Yeah. Okay. We'll have to roll anyways. I don't think we need to stick around to wait for the containers to be improved. It's just finishing the infrastructure as code changes to clean up everything that it deployed previously as well. Since the infrastructure, when we deploy through that, we'll do that for you, so we don't have to clean up after ourselves or anything like that. And if we wanted to as well, for the entirety of demo 2, we could run the same command, and we'll go ahead and do that to close up. We can run copilot app delete, and that should destroy everything for us. That will take care of destroying the services, that will take care of the environments, and that will take care of even the pipeline. Oh, Fargate and Sam, interesting. Okay, I don't think that was on the list, but I will definitely take that note of that. Thank you, Andy. Awesome. So we're cleaning up our test environment. We'll prod finish deploying before test and prod are deleted. Let's see who's going to win, the cleanup or the deployment. There's prod deployed. We got it before it deleted it. There we go. Cool. And we're just cleaning up now. So I appreciate everyone's time. Delete everything now. Definitely, if you deploy something in your environment, would definitely suggest cleaning up afterward, even though the Fargate containers you would deploy are very minimal. We want to make sure we're not including any charges, we're not using anything. So if you do any tests or labs yourself, clean up after yourselves just to make sure we're not leaving anything up. Awesome. Well, thank you. Have a good evening. Stay safe. Thank you for your time.